Hello, my name is Minjae Kim, and I am currently enrolled in BIO 152, and this is my presentation on resting membrane potential. So, we need to first go over the fundamentals of resting membrane potential, and the real question is, what is resting membrane potential? The resting membrane potential is the electrical charge difference across the neuron's membrane when the neuron is not activated. Normally, a neuron has a resting membrane potential of negative 70 MV, which means that when it is at rest, it is usually negative. This means that the inside of the neuron is more negative than the outside of the neuron. Resting membrane potential prepares the neuron to send action potentials when stimulated. Uh, One of the big things we need to go over when we talk about this topic is the sodium and potassium pump function. The sodium and potassium pump is a membrane protein found in neurons. It uses ATP to move ions against their concentration gradients. The pump moves three sodium ions out of the neuron, and the pump moves two potassium ions into the neuron. This means that more sodium ions are getting released than more potassium ions are coming in to the neuron. This creates a high sodium ion concentration outside and a high potassium concentration inside the cell. This helps maintain the neuron's resting membrane potential. Potassium leak channels are another big thing that we need to talk about. Potassium leak channels are always uh, open membrane proteins in the neuron. They allow potassium ions to exit out of the neuron. And the reason why potassium ions move out is because its concentration is higher inside the cell, because potassium ions are always moving into the neurons. And as potassium leaves, the inside of the neuron becomes more negative due to the fact that potassium ions are positive charged. This helps create and maintain the resting membrane potential because to maintain the resting membrane potential, it does need to be negative. So we need to talk about why the inside is negative. And as you can see here, in the neuron, the resting membrane potential always happens inside the axon. So more potassium leaves the neuron than it enters. This causes the loss of positive charge inside the cell because I talked about before, potassium is positive charge. So losing these ions would lead to loss of positive charges. Large negatively charged proteins remain trapped inside the neuron. Together, this makes the inside of the neuron more negative than the outside. And as I mentioned at the start, the membrane reaches a resting potential of about negative 70 MV. Well, thank you for listening to my presentation, and I hope you have a good day.